Ooh. There we go. Okay, so I have your packet. Is anyone else missing a packet? This was found. Is anyone missing their packet? You all have one? Okay. Anyways, our chapter is titled Quadrilaterals, right? We started off by finding angles. But now we are specifically talking about parallelograms, which is a specific kind of a four-sided figure. Here are just some real-life examples of parallelograms, because that's fun, right? Do you guys see the parallelograms on the eraser right here? Each side would be a different parallelogram. That yacht, boat-looking thing. All those windows would be parallelograms. They're all over the place once we kind of get into them. But there are 5 specific, I'm ahead of myself. Okay, let's define what a parallelogram is. Parallelogram is quadrilateral with 2 pairs of opposite sides that are parallel, hence the name parallelogram. You could spell out the word parallelogram when you want to name one, or you can use that symbol of a parallelogram. It's just a rectangle that's kind of like pushed over. But when you name a parallelogram, you just want to make sure you go in order of your vertices. So if you want to name this guy over there, I'm going to draw my little parallelogram. And you pick one vertex and then just go around. Which one should we start with? A. So we're going to go A and then just go clockwise. So parallelogram A, B, C, D. So as you guys can kind of see on this picture here, there's a bunch of different congruencies that happen within a parallelogram, and those would be its properties that we'll go over now. So there's 5 of them, okay? And you guys write down what number 1 in that box. Do you guys see how there's those boxes to fill in? So the first one is both pairs of opposite sides are parallel. So that's what you want to write in that blank first space where it says properties of parallelograms. So I got a picture, you would look for those arrow markings. Remember, those tell you that sides are parallel or things are parallel. All right, our second property is your opposite sides are also congruent. They're the same size. Both pairs of opposite sides are congruent. So they would either have like a tick mark, like up on the board, or just numbers telling you that they are the same. So your sides are both parallel and they are the same length. Now we're going to switch to angles. Opposite angles, so angles that are diagonal from each other, are congruent. Opposite angles are congruent. Bless you. Consecutive angles, so angles next to each other, are supplementary, so they add to 180. Brownie points if you can tell me why that's true.
I know. The 2 parallel lines.
Yes, right?
And they're alternate interior. Or no, they're
consecutive
interior.
Right. So remember, you guys, these are parallel, right? And we learned back in November that these angles next to each other added to 180 because they're consecutive interior. And same thing, these guys are parallel, so then these two would have to add to 180. You guys see how it all eventually comes together full circle, things that you learned help you for later on. Isn't that incredible? Yes. Okay. Last thing. Diagonals. So if you were to connect your two opposite corners, they would cut each other in half, those diagonals. So the diagonals themselves aren't the same length, but they cut each other in half. So like these guys could be like 5 and 5, and this might be like 7 and 7. They're not necessarily the same length, but they do cut each other in half. Okay? So I know it's a lot of information, but kind of with parallelograms, if something looks like it's congruent or the same as something else, it more than likely is, which is kind of a good rule of thumb. So we start off very basic with these examples. We're just looking for the missing measures. So if we wanted to find AD, what would you guys think?
8.
8, because opposite sides are congruent. What about DC?
15.
15, beautiful. Okay, angle A. What do you guys think? It is the same as C. How'd you get 112?
Equals 180.
Right, those guys on top of each other add to 180. So 180 minus 112 gives us 68. Oh, not 68. I did that backwards. $112. There we go. Okay, what about angle B?
68.
Yep, 68. Opposite angles are congruent. And then 112 for angle C.
112.
Yeah. If you guys want to get a head start on the next one, go for it. I'll catch up to you. Same kind of problem, just different numbers. Do we match? Is that okay on this one? We're good? Okay, the next one's specifically kind of more about the diagonals. Part of it anyways, but we'll just go through the motions here. What's UT? 27. Opposite sides are congruent. ST. That's it. All right, VS. Right, diagonals cut each other in half. So if this is 7, this half is 7. And then what about BT?
15.
How'd you get 15? Right, do you see that down here? The whole thing was 30, so this would have to be 15. Was that okay? Okay. I know your picture on the next one's kind of small. I'm sorry, but I'm going to have you label all of our missing angles, and then we'll fill this part in a second, okay? So I'm going to make this real big. Because it's a parallelogram, right? So we're going to have a bunch of like alternate interior angles that are the same because our lines are parallel. So I think this problem gets easier if you fill in all the missing parts, okay? So you guys notice how this is 21 right here? So this would be alternate interior to this guy right there. So I just label this as 21. Similarly, like this angle right here is 71. So that's alternate interior to this angle right there. So that was just all free information just on the givens, right? But then we notice angle FED, this bottom big angle is 134. So if I know this big angle is 134, how can I find the missing part?
134 minus 71.
Yeah, minus 71. Can you tell me what we get?
63.
63, right? So if this half is 63, we know up here is 63. Now we're just missing these other little guys. What do you know about this big angle E and this big angle F?
Equals 180.
They add to 180, right? So if this is 134, what does this have to be?
46.
Should be 46. So that's 46. If that part's 21, what would this have to be?
25.
25. So you guys give yourself a second to write all those in, just so you have an example in your notes, because there's one like that in your homework. And fifth hour didn't write them on their picture, and then they had no idea how to do it. So give yourself a visual, and filling in the other parts easy. So you just either look and we have the answer, or we add them together. Like for angle DEC, well, that's our 63. CDE. What do you guys put for CDE? Yep, add them together. ECD, 71, perfect. DFE,
25.
I agree. Is that okay? Okay. Now we're gonna try a little algebra, same thing, using our properties to find the variables. Nothing crazy.
Oh, because they're next to each other.
What variable do you guys want to find first? X, Y, or Z?
Y.
Y. So those are our diagonals. What do you guys know about those two chunks? They do.
This minus 1. Y equals 9.
Yep. Y should be X or Z? Z? What's our equation for that?
3z equals 95.
Ooh.
33.
Right, so what kind of angles are those?
Alternate interior.
Beautiful. So you have 11? X. X, where do you see X? 5x is equal to what?
26.
Right.
5.
I think it should be 5.4. That wasn't too bad, was it? You guys get a head start on the next one, which most of you already have. I'll catch up to you. Bless you. How we do? Doing okay? Okay, then our last one requires a little bit of coordinate geometry. Don't let that freak you out. We just have some ordered pairs we're working with. So we are looking for the intersection of our diagonals. What do you guys know about the diagonals of a parallelogram? Yes, we're cutting them in half, right? So where should they intersect at? The midpoint, right. You guys remember how to find the midpoint of something? What's the midpoint formula? X what? 1 plus, there we go.
X2.
X2, there we go. All over 2, and the same with your y's. Y1 plus Y2, all over 2. So I would write down your formula. That's the midpoint formula. And I'm going to draw a little picture just so we have a visual. Here's my terrible parallelogram. F, G, H, J. So how do I know which pairs of ordered pairs to use? Which two go together? Right? Here D1 diagonal. What's my other one?
G and J.
Yeah. So let's find it for FH first. So now you just look at F and H and plug into our formula. So let's see here, -2 plus 2 all over 2. And 4 minus, well, plus a -3 is really just subtracting, right? Did I get 0 and 0.5 for that one? And you have to do it to the second one as well, just to make sure you get the same thing. So now plug in for GJ. Make sure you get 0 and 0.5, otherwise I think something happened. Did your guys' match? Yeah. All right, then I have you do one more thing in your notes. You guys finish this sentence for me on the bottom. A parallelogram is whatever you want to write. Finish that sentence. A parallelogram is I would probably be unoriginal and say is a quadrilateral with both pairs of opposite sides parallel.